Suppose we are asked to differentiate a particular function, let's say y equals x raised to the power 3 from first principle. How are we going to go about this? Of course, the first step to take is to add an infinitesimal change to both sides. So if you do that, we have y plus the y equals x plus the x, then all raised to the power of 3. That is the first step. So let's call it step 1. Then the second step is to subtract y from both sides so as to make the y stand alone. So if I do that, I have y plus the y minus y equals x plus the x raised to the power of 3 minus y. And as soon as you've done that, you will agree with me that y will cancel minus y and we are left with dy is equal to x plus the x raised to the power of 3 then minus y. After doing this, we would have to expand the terms in the bracket. So this takes us to the step 3. If we want to expand that, we have x plus the x raised to the power of 3. This is the same thing as saying x plus the x raised to the power of 3, which is equal to x plus the x times x plus the x times x plus the x. But this is looking cumbersome because I'll have to multiply these together, then the answer from the multiplication of these two will not be used to multiply this. It's looking very, very stressful. And that is why we're going to use a particular method known as the binomial expansion. And how does it work? It is simply the method used to solve for the expansion of a higher order exponent. The method we would use here to expand binomially is called the Pascal's triangle. And how does it work? Remember, I said earlier that the Pascal's triangle is that particular method we use to find the coefficient of the terms. So let us start with 1. We have to expand this and we have 1, 1 on both left and right side. So if you do this, this 1 will be brought down here and we add these two together to give us 2. Then we'll bring this 1 over here. Let us continue. 1, 3, 1 plus 2 is 3, then 2 plus 1 is 3, and then this 1 will be brought down here. What will we have? 4. We have this 1 will come down here. 1 plus 3, 4, 3 plus 3, 6, 1 plus 3, 4, and then 1. What do all these stand for? These stands for the constant. This is the coefficient of the constant, and this stands for the power of the independent variable raised to the power of 1. So when the independent variable is raised to the power of 1, then 1 and 1 will become the coefficient. What if we go to the next one? This is for the exponent of 2, and this is x raised to the power of 3, and this of course is x raised to the power of 4. Okay, so if we check our point of concern, our area of concern, of course this is what we are concerned about. So we would have 1, 3, 3, and 1 as our coefficient. How do we expand these further? Let us go to the next slide. Still under step 3, we have x plus the x raised to the power of 3. And from Pascal's triangle, we are told that the coefficients would become 1, 3, 3, and then 1. So if we want to expand x plus the x raised to the power of 3, this is how we'll do it. We'll take x raised to the power of 3, the x raised to the power of 0. Remember, the terms in between these particular expressions are x and dx. So x takes the entire power while the x takes a power of 0 plus x power will reduce by 1 and the x will increase by 1 plus x power will also reduce by 1 and the x power increase by 2. And the final one is x will be raised to the power of 0 and the x will be raised to the power of 3. So we have x raised to the power of 3, the x raised to the power of 0 plus x raised to the power of 2, the x raised to the power of 1 plus x raised to the power of 1, the x raised to the power of 2 and x raised to the power of 0, the x raised to the power of 3. Remember we said that anything raised to the power of 0 in indices is equal to 1. So if we do this, we still have x raised to the power of 3 times the x raised to the power of 1 is still the same thing as what? X raised to the power of 3, then plus x squared the x raised to the power of 1 plus x raised to the power of 1 the x squared. Then since x raised to the power of 0 is equal to 1, so we have 1 times the x raised to the power of 3 will give us the x raised to the power of 3. And the next step from here is to include all the coefficients from the Pascal's triangle, these ones here. So if we do that, we have x raised to the power of 3 times 1 plus 3x raised to the power of 2 the x raised to the power of 1 plus 3x raised to the power of 1 the x raised to the power of 2 then plus the x raised to the power of 3 times 1. And since anything multiplied by 1 is still that particular thing, so we have x raised to the power of 3 plus 3x squared the x raised to the power of 1 plus 3x raised to the power of 1 the x raised to the power of 2 plus the x raised to the power of 3. This is not our focus. We just use binomial expansion to expand our term. So let's go to the initial problem. This is where we are. So taking a step further, leading us to step 4. The step 4 simply is, remember we have dy equals x raised to the power of 3 plus x squared the x raised to the power of 1 plus x the x raised to the power of 2 then plus the x raised to the power of 3 minus y. Remember we said y would be taken to the other side so as to make the x here stand alone. And from our first question, we're told that y is equal to x raised to the power of 3. So if we substitute x raised to the power of 3 for y in our step 4, then this will give us dy equals x raised to the power of 3 plus x raised to the power of 2 dx plus x the x raised to the power of 2 then plus the x raised to the power of 3 minus x raised to the power of 3 since y equals x raised to the power of 3. And you agree with me that this will cancel out because x raised to the power of 3 minus x raised to the power of 3 is equal to 0. To include those coefficients from the Pascal's triangle, we have this, and this is 3, this is also 3, plus the x raised to the power of 3. So if we go over to the 5th step, remember in our previous class, I gave all the steps we need to take while solving for the differentiation from first principle. So the next step, if you could remember very well, is to divide through by dx. Is to divide through by the small or infinitesimal change in x. To do that, we have to divide through, then let's put step 5. So step 5 is to divide through by dx. We have dy over dx is equal to 3x squared dx then plus 3x the x squared plus the x raised to the power of 3. So if we divide through by the x, divide through by the x, divide through by the x, we would now have to cancel these out. So cancelling out, this will be left with 1 and this will be left with 2. So this simplifies to dy over the x is equal to 3x squared plus 3x dx plus the x raised to the power of 2. Now the next step, which is almost the final step, is to take the limit of the left hand side. So if we take limits, this is step 6, take the limit of the left hand side as the x tends to 0. If we do that, we have lim the y over the x as the x tends to 0. Remember, I said in our previous class that as soon as you take the limit of the left hand side, it becomes the full differential or the complete differential, which will be at a point where the x will tend to 0. So having said that, as soon as the x tends to 0, every other term that has the x on the right hand side tends to 0. Take note. So if we go to what we had here, so as soon as we take the limit of this right hand side, every other value on the right hand side that has the x term will tend to 0. So what do I mean? What we just have here is dy over the x will be equal to 3x squared plus 3x dx, then plus the x raised to the power of 2. So all these terms, these and these, will tend to 0. That is, they will become 0. And if we have that, our final answer becomes the y over the x is equal to 3x squared. This becomes our final answer. Now, I told you previously that whichever method you use, be it first principle or the formula method, you just must get the same answer. So let us check using the formula method to know if we got the same answer. Now, how do we do that? Remember, the function still remains y equals x raised to the power of 3. And we're asked to find the y over the x. Now, I said from the formula method that the y dx for x raised to the power of n will give us n times x raised to the power of n minus 1. So if we do that to the equation or the function we have over here, it will give us y, the y over the x will definitely give us 3x raised to the power of 3 minus 1, which will give us 3x squared. Compare this with what you have in our previous slide. You realize that we have the same answer. So whichever method you feel like using in your exam, you're good to go. Just make sure that you have the same answer. Mind you, if you're not specified to use first principle or the formula method, I would advise you to always use your formula method because it takes you to the answer faster. So in our next class, we will discuss the rules or the laws in differentiation, and I'm sure you don't want to miss it. So see you in our next class.